So with that, I would like to introduce my guest, Arvid. How are you?
I'm good. Thank you. Thanks for having me.
Of course, of course. Why don't you begin, as we did with the podcast, telling the story basically of how you came to write your wonderful book, which has been highly praised, The Gene's Eye View of Evolution, Oxford University Press, 2021. How you came to write the book?
Yeah, so I started thinking seriously about writing this book a couple of years ago. And it was a time in my life where I was feeling kind of simultaneously very confident about myself, but also very insecure about what would come. I had just gotten this fellowship, the Swedish fellowship that had taken me to Harvard, and I had all this time and freedom to do whatever I wanted. But also felt very nervous of whether I would kind of make it as an academic, or what's going to come of this. And those two things kind of coalesce around the idea that I might just do what I really want to do now, because if it's going to work out or not, I should at least try to do this. And what I wanted to do was to write a book about the gene's view of evolution, because I'd been fascinated by this debate for a really long time. And I think for me, it really started when I came to Toronto, Canada, to begin my PhD. So I grew up in Sweden, did my undergrad degree in the UK, and I think I had really internalized a gene's view of thinking. That was kind of what I was taught at school. When I came to university, that was kind of the prevailing view. And then I came to Toronto, and for the first time, I was surrounded by North Americans, and it seemed like both my kind of peers, my other graduate students, they had often quite a different view on the world than I did. And I thought that was really interesting. And often to exaggerate or overgeneralize a bit, it seemed like I had been given a book by Dawkins when I was 16, and they had been given a book by Stephen Jay Gould. And I think we both had kind of internalized that, and that kind of came to a head when we both arrived in graduate school. And this wasn't helped that when I would go down the corridor at the department, I would ask one of the senior members of the department, what do you make of the gene's view? And one of them, they would say, oh, this is the way, and the light in the way. This is the way to think about it, and everyone knows that. And then I would go 2 doors down and knock on another door, and they would say, oh, this was debunked in the 80s, and everyone knows that. And I thought here kind of is something interesting. It's something here kind of about the way we think, and kind of it's not necessarily it's not something that straightforward, right or wrong. It's not something that can be disproved by a clever experiment or an ingenious mathematical model. It's something more about kind of how we perceive the world. So fast forward then about 10 years or so, I thought, I know, I really want to do this now. And then so that's what I started out doing. And then kind of when I had just started, I just signed a contract with OEP. The pandemic came, and everything all other kind of projects suffered. But this turns out book writing is something that you can do rather well on your own. It transposes rather well to pandemic living. So whereas kind of everything else kind of crackulated, and I had no teaching or caring responsibilities, I was able to crack on rather well with this project. And it was so much fun, and it was a really exciting thing. But on that way, it was.
Great, thank you. And a very highly praised book. You've done lots of interviews on it, actually. And when I read it, I loved it, and I loved it in part because I felt I agreed with so much of it. And of course, I'm a critic of selfish gene theory. That's the way most people think of me. But actually, for me, it showed that how much progress has been made over the decades, and how much there's a sense in which the major issues have been resolved. And it's really the overlap of our views. So whether we have some differences, but there's really the overlap that I feel is most worth stressing. And so with that, let's get right into our 8 points. And the first one is, and we're going to take turns introducing these points and both discuss them. So the historical origin of the gene's eye view and the importance of Paley, Fisher, and Hamilton. So Arvid, why don't you begin on that? And please, if you have questions or comments, please enter them into the chat, and we'll have a record of this conversation, including input from our audience.
Yeah, so at the beginning of the book, I tried to make this case, or what I see as kind of this 3 legs, or kind of 3 strands of thought that kind of makes up the core, the intellectual core of the gene's eye view. And I think they can be represented by Paley, Fisher, and Hamilton, and kind of taking them in turn. I think so. The first Paley then I think can be taken to represent kind of the focus on adaptation. So the kind of this notion that is adaptation or the appearance of design that is the central problem of our field, that this the kind of the thing, the special problem that evolutionary biology is set out to try to solve is how to explain adaptations, what they are for and how they came about. And Paley is kind of special then, I think that, so he was the writer of natural theology. He was a apologist as the 18th was turning into the 19th century. And he wrote this book called Natural Theology in 1802, which is a beautiful book. Like so he lays out kind of from what you can learn about the divine world from studying the natural world. It's kind of he is the one who in English popularizes the watchmaker analogy, that if you find a watch, that implies that there's been a watchmaker. And then the kind of the leap that he makes is that the natural world is even more complex than what a watch is. So that too then implies the presence of a creator. And it's a wonderful book. He kind of walks through different kinds of animals. He doesn't dwell too much on plants because, you know, why? Because as he puts it at the beginning of the chapter, why dwell on a weaker argument when a stronger one is at hand? But it's a beautiful book, and you know, Darwin was very taken by it, and so were kind of subsequent generations, or particularly English evolutionary biologists, even though they often use it more in rhetorical purposes. You know, Dawkins wrote the Blind Watchmaker, but also you have people like, you know, John Maynard Smith have all these kind of references to Paley, and even to this day, you know, some of our contemporary colleagues, you know, Andy Gardner and Alan Graff and others kind of make appearances or make kind of appeals to that and kind of to show that this is the problem. So I think this kind of highlights a tradition in biology that takes adaptation to be the central problem that we're trying to explain. So I think that kind of highlights the first leg. The second is that it picks up on the emergence of population genetics. So the genes have you know, really come to its own in the 60s and 70s. So of course, the selfish gene is the introduction for a lot of people, but 10 years before that, George Williams writes Adaptation and Natural Selection, a book aimed primarily at professional biologists. But there, it kind of, I think it's not just population genetics idea you can describe evolutionary changes in allele frequencies. I think it is the Fisherian way, which is kind of more focused on individual alleles than, say, like Sewell writes. But in particular, I've been trying to make this argument that it's Fisher's notion of the environment that is really kind of like the radical idea in his thinking, that he's kind of, and he lays this out in the 1918 paper where he introduces the notion of variance, that where he's interested in kind of what is calculating the effect of replacing one allele with another. So going from being homozygous for one allele to heterozygous to a homozygous for the alternative allele. And to do so, he needs to keep the environment constant because he want to isolate that effect. And in so doing, then he introduces this quite subtle but radical shift in what the environment is, because to do that is not just the environment around, pH, temperature, presence of predators or whatever, but it's also the rest of the genome. So from an alleles point of view, the other genes in the genome or all the alleles segregated in the gene pool are as much part of the environment. And this is kind of a notion that comes up a lot in George Williams and in Dawkins writing. So that's why I think like Fisher stands above the rest in this population genetic strand of it. And then thirdly, I think you can kind of broadly construe as kind of like a moment in time as much as a specific way of thinking. I think it's kind of broadly the rejection of kind of Wynne-Edwards style group selection. It's a major focus of Williams's early writings, a major focus of Dawkins' early writings, and kind of in particular Dawkins described the kind of the four heroes of the selfish gene to be, in addition to Williams, is John Maynard Smith, Robert Trivers, and then Bill Hamilton, all whom had alternative ways to explain social behavior that was centered on individual organisms rather than appeals to group or species benefits. And in particular there, I think Hamilton, again, stands above the rest, and his notion of inclusive fitness is particularly important. It has a very intimate relationship with the genes I view. And to the best of my knowledge, if you want to trace back the first time the term selfish genes, or the genes will be selfish in this kind of way, it is in the notes that Dawkins prepared when he was a graduate student, and his advisor, Nico Tinbergen, was away on sabbatical, and he had been asked to stand in to be a lecturer delivering the lectures in animal behavior. And being nervous for the job, he had typed up his notes. So in the mid-60s, he still has those notes where when explaining the concept of inclusive fitness, he describes for the first time, to the best that from what I can tell, genes as being selfish, that should be the expectation. So that's why I think kind of like Paley represents taking what is the central problem of evolution. Fisher is a particular way of centering it around genes being the central way of explaining then the problem. And then I think kind of this Hamiltonian moment is kind of when it's beginning to make sense of things that don't really are easy to explain from the perspective of the individual organism, but you have to kind of appeal to something else. And it's part of a movement then to reject appeals to group or species level benefits and instead focusing on lower levels. So that's why I think those three can be used to highlight that kind of three threads as they come together in what I think that kind of has the two books that represent the beginning of the gene side view. That is the Adaptation and Natural Selection by George Williams, and then the Selfish Gene by Richard Dawkins.
Yeah, and I'd like to, before we move on to the second one, to add, and I've come to appreciate this more and more as time goes by, that what took place in evolutionary biology was part of something larger that took place, which is the broad tradition of individualism. So at the same time as what Arvid just recounted, we have the advent of neoclassical economics in economics, Homo economist, and we have the advent of methodological individualism in the social sciences. And so it seems that like across the board is some kind of tide that lifted all disciplinary boats. We have a focus on the individual organism as a fundamental unit and the need to understand all things social as some variety of self-interest. And as we'll get to later on, you know, Hamilton's variety of self-interest, inclusive fitness, was different from selfish gene theory. So there's quite a lot of variation in different conceptions of individualism. But so it's important not to encapsulate what took place in evolutionary biology. It's important to see it as part of a larger social history. Okay, now let's get to the second one, which is very much cut from the same cloth, and it has to do with really the importance of functional design as just probably the most central aspect of evolutionary biology. It's what Paley was emphasizing, basically. How do we explain the existence of functional design? So Arvid, go ahead and take it away.
Yeah, so I think I can keep it rather brief for this one, but it's something I've been thinking about more so recently, that like I think a lot of debates that we may have in biology has as a component that we often disagree. What is it that we're trying to explain? So what is the problem? Because I think that feeds in then to a lot of disagreements about what a good answer looks like. Because if you can't agree what the problem is, you often cannot, and then you don't agree what the solution looks like or what a good answer to a problem looks like. And I've thought about this a lot in the context of recent debates over inclusive fitness theory, that during the last 10, 15 years, there's been a lot of debate about the soundness of the mathematical framework underlying it, spurred most recently by the paper by Martin Novak, Ed Wilson, and Corina Tarnita in 2010. And having talked to a lot of people on both sides of that over the last 10 years, I feel like a lot of how willing you are to live with the weaknesses of the mathematical weaknesses of inclusive fitness, which I think everyone on both sides of it agree that there are some, comes down to whether you think adaptation is a central problem. It's like a kind of a uniquely special problem, because I think then because a lot of the benefits of inclusive fitness theory has to do with that. It provides a kind of uniquely good way of doing that, an individual-centric explanation of adaptation. So it's kind of something I kind of keep thinking about, and how that feeds into various disagreements that we may have. And I think the gene side view and inclusive fitness are so intimately linked, and they very much share origin, and they have walked hand in hand for so many ways. I think there are interesting nuances in that, and when the two perspectives have come into conflict, and I think we'll get to them later on. But I think that they're very much part of that kind of tradition of wanting to explain adaptation and doing so in a particular kind of way.
Yeah, I definitely agree that the centerpiece of Darwinian evolution is the appearance of functional design. And that functional design, the study of functional design not only enables, but also demands a certain kind of analysis. That if we take, for example, either a human implement such as a watch, to go back to Paley, or an organism, let's say a solitary organism such as a fruit fly, then it really demands that the organism or the functionally designed object is the fundamental unit. You analyze all of its parts in terms of their contribution to the function as a whole, and the object exists in some larger milieu, such as, fruit flies exist as populations of fruit flies and as ecosystems containing fruit flies, but those populations and ecosystems are not like an organism. And so the organism becomes a kind of an anchor of analysis that informs how you study everything below it and everything above it, but in different ways. And you really, if you don't do that, then you're not going to make as much progress as if you do. And so that is an important piece. It's not really evolutionary per se, because it can be applied to a human implement, for example. And so it's really a statement about the analysis that's required for any functionally designed entity. But of course, the only source of functional design is an evolutionary process, or the creation of an evolutionary process. So Arvid, do you want to comment on that whole piece before we?
Yeah, maybe only to say that, like, I think somewhat, I feel like I've become more adaptationist with age. That I think sometimes people who are not trained in evolutionary biology can often be kind of naive adaptationists, and you kind of like learn to appreciate the nuances of other things that lead to biological diversity. But then I think kind of with an appreciation that I think organisms is what makes biology unique, and that organisms have clearly just like physical objects, just like anything else. They're subject to the same laws of physics like everything else, but clearly also different from anything else, that they have something. And I think that what makes them unique is adaptation. I do think adaptation has a special role to play in biology. It's kind of part of what makes biology what it is as a scientific.
Yeah, but having said that, of course, we have to. I can't with Randy Nesse staring at me from his image, I have to add a lot to this. That of course, and this is where Stephen Jay Gould comes in. Yes, adaptation is the centerpiece, but of course, there's a whole non-adaptive side to the evolutionary coin. We've got byproducts, we've got mismatch, we've got all of this stuff. And so I think that what's amazing about evolutionary theory is that it is capable of identifying both the presence and the absence of adaptation and the level of adaptation. Are we talking about an organism? Are we talking about a social insect colony? Are we talking about a cancer? Are we talking about meiotic drive? So both the presence and absence of functional organization and the level of functional organization on a case-by-case basis. There's no single answer. You just have to figure it out on a case-by-case basis. And that's really amazing when you think of it, that we have a conceptual toolkit basically to enable us to determine that.
And I think that's also striking about adaptation and natural selection, George Williams's 1966 book, which is very much, I think, is adaptation is in spirit and at the heart of it, but it's also like a call for taking the study of adaptation seriously. That, as you said, is an onerous concept that shouldn't just be thrown around. It demands and requires careful study before you invoke it. And I think that is absolutely the right spirit.
Yeah, exactly. I'm going to put up 3 and 4 together. And now it's my turn to initiate the conversation. So what I call the original problem, because it was encountered by Darwin, and it very much follows upon this adaptationist thinking, what he discovered, and it was gradual, is that his theory, which he thought that could explain all examples of design that had been attributed to a creator, actually could not explain one important class of adaptations, which was anything prosocial, anything done on behalf of others or one's group as a whole, actually places the prosocial individual at a selective disadvantage compared to the individual who accepts social benefits without returning them, or actively exploits the prosocial individual. So there's selfishness beats altruism within groups. If you look at natural selection at the finest scale of the individuals that are actually interacting with each other, then you find that this relative fitness disadvantage. So he could not explain anything prosocial. Of course, that's a huge class of behaviors, unless he added something. And what that something is a selection differential at a larger scale, that even though the prosocial individual was at a selective disadvantage compared to its immediate neighbor, groups of prosocial individuals would robustly outcompete other groups. And that was the birth of group selection. Darwin is the one who had the first insight. And it's inevitable. If you fast forward to the present, whatever you might think about the group selection controversy, you can't disagree with that reasoning. That's just a biological fact of life. It just comes with prosocial behavior, this selective disadvantage, this trade-off. And so we really need to keep in mind the original problem, as I call it, as something which is still a fundamental problem that needs to be solved, no matter what the theory. Selfish gene theory needs to address this. Inclusive fitness theory needs to address this. It's just baked into all theories of social evolution. And so, Arvid, why don't you comment on that, and then I'll get right to basically this period of with G.C. Williams and others.
Yeah, maybe I was kind of, I think where this is leading, I think kind of is where how did the genes have used rejection of it. So I was thinking maybe you could introduce the next point as well, and then I think we can have a discussion about kind of how the genes have you, and then I think inclusive fitness and kind of group selection or multilevel selection views like what the answer ought to look like in a slightly different way, like what the good answer look like.
Yeah, so I think that so basically the book by George C. Williams, Adaptation and Natural Selection, is the most important book, I think, of the period. I think you'll agree, Arvid, and Dawkins's book was built upon it. But in that book, Williams did two things that need to be distinguished from each other. In the first place, he accepted the logic of the original problem, which I just described, and he argued that, yeah, that's right, no group level adaptations without group level selection, but as an empirical fact, it just turns out to be true that group selection is almost invariably weak. And so within group selection carries the day, and group selection as the group level adaptations do not in fact exist. That's a direct quote from his book. And so that was one strong argument, basically accepting the logic of multi-level selection and then rejecting it on the basis of the empirical claim that between group selection is invariably weak. And then the second concept he developed was this gene's eye view, that we can actually see the world through the lens of the genes. He called it an accounting method. So that's very interesting. And the most important takeaway message is, don't confuse those two arguments. Those are apple and orange arguments. Please don't confuse the concept of genes as replicators as an argument against group selection. I call that naive gene selection. And I think that Arvid's going to agree with it. I mean, we've already talked about it, but it should have been obvious from the start. But historically, and actually to this day, there are people who say that because, you know, the gene is the fundamental unit of selection, which is invoking the replicator concept, then therefore that poses some kind of argument against group selection. If we're going to talk about group selection from the gene's eye view, we have to invoke the concept of vehicles. It's vehicles where you're going to find the group selection controversy. So there we go, Arvid. Now I have more for you to comment upon.
Yeah. So I mean, I think that distinction, I think it's interesting. So first, it's kind of like the empirical claim: how important is group selection in natural population? How important has it been in evolutionary history. And as I say, I think I agree that that is an empirical question. Now, in trying to answer it, though, of course, we sort of have to make kind of like you get into kind of more conceptual issues, because then one is something that's basically, what do we mean by a group, right? So if you take Maynard Smith's classic haystack model from 64, it's kind of something quite, it's discrete, it's physically separated. They don't, it's something kind of you kind of see out there, and you contrast that, for example, with the trait group selection models that you have been so instrumental in, where like it's something much more fleeting. It's not something that is just, and so kind of like part of answering the basic empirical question is going to be an conceptual one of what we mean by it. And then kind of like this is the kind of genes as the fundamental unit of selection, and an argument against it. And I think you're right that it need not be that, right? It's because I think the way that, and I think this kind of comes in then to like how we construe what the answer should look like. So to the genes I view, the question of adaptations, whether at the individual level or at the group level or elsewhere, is what I think what Lisa Lloyd has called the beneficiary question. So Lisa Lloyd, as a philosopher, did an enormous job, I think, in kind of cleaning up the debates over the levels of selection. She was one of the group of philosophers, I think, who really made a big contribution to the science of evolutionary biology. And she distinguished and kind of like the beneficiary question, like when we say that an adaptation is for the good of something, what is that something? And for the genes I view, I said that genes or replicators are unique in that they are the only thing that can satisfy the requirement of kind of longevity and fidelity being passed on in intact enough of a structure from one generation to the next. So that I think is like, it's a way of conceptualizing what the answer to the problem of adaptation or design should look like. Because I think you can contrast that then with the sister concept of inclusive fitness, who conceptualizes the answer in a slightly different way, where there the answer is that organisms clearly have adaptations. So then the question is, well, what are they trying to maximize? Like, what is the maximum in some sort of design function? And then they say, well, it clearly can't be personal fitness, because you look at these traits that are advantageous. They are harmful to the individual, but beneficial to others or to a group. So it can't be personal fitness, it has to be something else. But then they say, well, it has to be then inclusive fitness, that the organism should appear as if designed to try to maximize, because then they make all this sort of argument that inclusive fitness has these unique properties of being under full control of the individual, and it's actor-centric and all that. But then again, it's a slightly then different kind of conceptualizing of what the answer to this, you can agree on the problem, but you have a slightly different and kind of like conception of what the answer should look like. And I think kind of like the multi-level selection has a slightly different way of conceptualizing what the answer should look like again.
Yeah. So well, I think that and I'm really kind of curious to know what our audience is thinking of all this. Hopefully not getting too much in the weeds. But I think that often when you go to the logic of the original problem, often the group is clear enough what the group is. And again, my good friend Randy is right here, and in his book with George C. Williams, Why We Get Sick, then they take the case of virulence, basically disease virulence, and there it's pretty clear cut that within a single host, if you have a strain which is reproducing faster than another strain, then the advantage goes to the more faster reproducing strain. And if that results in the death of the host, that's something which is a group level cost. And so basically there's going to be selection within hosts in favor of greater replication. And then there's a counterforce, which is the differential deaths of the host. And Williams himself, despite his 1966 book, and Randy said, yeah, that's an example of group selection. We have an example of group selection in the evolution of reduced virulence in disease. And then at the same time, as all this was happening, we have, let's mention the name of George Price, who came up with an equation that actually was an elegant partitioning, so that in the equation, you could actually see a component of the equation referred to what was taking place within groups, and then another component of the equation was taking place between groups. And that equation made it a little bit more transparent that you can get something evolving in the total population, despite the within group term being negative, because the between group term was sufficiently positive. And so when Hamilton saw the price equation, he said, oh, wow, now I see how group selection works. And in fact, my own inclusive fitness theory can be translated into those terms. So all of these were taking place, and this brings in the concept of pluralism, the fact that somehow in the kind of the parable of the people in the dark room groping the elephant, we're creating these different mathematical models for social evolution that really seem different from each other, but actually they're not invoking different causal processes. They're studying the same causal processes in different ways, and it's taken a long time. Decades were required, and it's not entirely complete for us to really converge upon this idea of pluralism, that there can be multiple different theories, more than one theory, that deserve to coexist by virtue of their perspectives, but there is a way to translate between them, so that whatever you say evolves according to one of these, then you can say, okay, here's how the same thing evolves according to another. And so pluralism is not restricted to the group selection controversy, but I think it's something that's you can't understand selfish genes and inclusive fitness and group selection without this idea of pluralism and equivalence. And there's a pretty sizable philosophical literature on that. Arvid, why don't you say a bit about that, and then I'm going to, in the interest of time, I'm going to bring the next two up.
Okay, yeah, but just kind of quickly about, I think pluralism and kind of the equivalence between different mathematical framework, I think it's a very interesting question, and it's one that I change my mind on almost from week to week, what really to make of it, because I think you're absolutely right that you can think of these as, you can formally show how, say, for example, inclusive fitness and group selection models can be mathematically equivalent, and I think that has done an enormous job to kind of like move the debate forward into more interesting territory than rather than just kind of making it which one is more right and one is right and the other one is wrong. I think it's kind of moved it into thinking about more interesting questions. I think we should be careful when we talk about causality here, because just because you can describe something in two ways, that does not necessarily mean that they are kind of causally, or they kind of causally the same. I think often this kind of like equivalence is achieved using a very like abstract statistical notions. So like where you kind of almost moved quite far away from kind of the intuitive definitions of the concept. So here again, I think so like Jonathan Birch, the philosopher of biology, has done very nicely, where he kind of highlights that you can kind of the equivalence between group and kin or inclusive fitness, kin selection, you can kind of have, he describes it as kind of like both the notion of what a group is can slide from something very discrete and very like highly integrated thing, like that an organism, a multicellular organism, is a group of cells. So they have very high relatedness, they're clonal, they're physically very integrated. That is a form of a group, right? But it's also kind of groups that are much more fleeting. And similarly, you can kind of have this varying according to relatedness. So kind of you can kind of like partition this out on that kind of axis almost, so like how much relatedness do you have in this group? How kind of clumpy are they? And I think that's kind of like that. I think is very good. Like trying to partition out then, because then you can kind of return to kind of William's original question: how important has group selection been? And then I think you can kind of like be clear about what along these axes are you actually referring to. And I think that is a really interesting. Then you kind of move into empirical questions.
Yeah, let me make a quick point about that, because I feel that there's more clarity on that in any particular case. And I sometimes call these stubborn truths about any biological situation that they're trying to model. Take any real world concept like warning cries or resource conservation, or any model of social behavior that you're trying to model. And one of the first things you need to do is you need to know what's the fitness of an individual organism, But if it's a social behavior, that's going to depend not only on the phenotype of the organism, but on the others with whom that organism interacts. That function is going to be it's going to be a function of the, and you have to specify that. Biologically, you have to specify that. And it doesn't matter what framework you're using. You can't even assign a fitness to an individual organism unless you understand the set of other organisms with whom it interacts. And so there's no wiggle room there if you're going to actually capture the biological details. And so I think in some ways there's not there's a less it's not arbitrary how we define our groups, but I'm going to race ahead here just to get in the interest of time. And so we've already talked about pluralism, but could you say a little bit more? I mean, a lot of people think that the gene's eye view and inclusive fitness theory are kind of very compatible with each other, but actually no. And you've touched upon that a little, but I think that Arvid, maybe elaborate on that, because I think that will be quite new and surprising to some people, that there is tensions basically between those two theoretical frameworks before we even get to group selection.
Yeah, so I guess the first thing is that like they are intimately linked for a reason. Like it's very much the same people who are involved. I think most of the time there will be two sides of the same coin, that like you can conceptualize it as an individual maximizing its inclusive fitness, whereas kind of replicators are striving for their own self-preservation. I think that will work most of the time. And of course, Hamilton, his first two papers, so his very first paper was published in 1963, which was a little note in the American Naturalist, where he introduces what we now know as Hamilton's rule, a term that would come later. And then a year later, he has this kind of majestic two-part paper in General Theoretical Biology where inclusive fitness is introduced. But he wrote this short little brief thing, kind of very much on the urging of his PhD advisory committee that he needed to get something out. But there he is relying on a gene's eye view. It's one of kind of the earliest clear articulations of a gene's eye view. And Hamilton himself would kind of oscillate between it. So I think he deserves kind of credit for kind of the origin story of the gene's eye view. But then inclusive fitness then isn't, at the end of the day, is an organismic, individual-centric point of view. It's a theory about individual organisms. And it kind of I think there are kind of two tensions here that I think are interesting. One is kind of like a historical cultural one, and one is a more kind of biological one. The historical cultural one is that there's a fun irony in that when you read kind of a lot of kind of criticism of inclusive fitness, it's been that it's this kind of mathematically cumbersome thing to calculate. It's very easy to get wrong. For a lot of social situations, it can be hard to do it right. And wouldn't you, at the end of the day, be better off just focusing on something else? And that is a critique that has been kind of echoed, like John Maynard Smith described inclusive fitness as an absolute swine to calculate, which it often can be. And Dawkins has also had this kind of like criticism, very friendly, but criticism nonetheless of Hamilton for not really committing fully to his own revolution. That Hamilton was instrumental in bringing the gene's eye view about, but then he kind of like still stuck to the individual. He didn't kind of wanted to dethrone it, which kind of the gene's eye view want at the end of the day to kind of get rid of the organism.
Well, more than that, Arvid, I think in his autobiography, Hamilton says that he was trying to make it sensible to the reader, and he thought one way to make it sensible would be to describe it like an individual making a cost-benefit decision. And the only way to do that, of course, is to say that the individual is attempting to maximize the copies of its genes in both itself and others. But I think that his own incentive to do that was to make it intuitive by turning it into an individual decision-making process. It's a great example of someone trying to, fit the theory into the mold of individualism, as I was talking about before.
Yeah, and I think and that's probably also part of why it's been so popular about people who do study animals in the wild, because that's kind of what you see. You see organisms doing things. So it's like having a theory that is in those terms is extremely helpful. So kind of, and the kind of more biological thing is that, like, in order to do inclusive fitness maximization models, an individual maximizing its inclusive fitness, often what you have to do is that assume that all parts of the organism are working for the same. There's no kind of internal conflicts, so to speak. And I've been very interested in so-called genetic conflicts, biology of selfish genetic elements. Currently, I've also started to work on cancer. So things that are kind of happening, selection and conflict, social evolution happening inside of organisms. And often I have found that, like, too much focus on the individual as a central unit makes you miss that. Because I think one of the beautiful things about the Gene Side View is that it forces us to look at organisms in a whole new light. So we currently have this grant, a colleague and Amanda Patton and I from the Templeton Foundation called it the paradox of the organism, which is an old Dawkins term about the paradox of the organism. Why aren't organisms torn apart by its kind of competing entities? Why is that what holds it together so that organisms are these salient units out in the natural world? Why aren't they broken apart by genetic conflict, by cancers and so on? So I think that is kind of like where I think that it's not that you can't use inclusive fitness maths to study these things, but I think they kind of like too much focus on individual organisms makes you miss out on the exciting things that happen inside of them.
In the comparison between inclusive fitness and theory and selfish gene theory, that is indeed where inclusive fitness theory fails. There's no way you could explain cancer or meiotic drive as good for the individual. Just cannot do. And then people tend to sweep that under the rug by saying, well, it doesn't happen very often. But I'd just like to add, before getting on to our final 2 points, that a multi-level selection theory handles genetic conflict very well also. And so in that nested series of fitness comparisons, it's between genes within an individual, between individuals within groups, between groups within a multi-group population. And so multi-level selection handles the genetic conflict case as well as selfish gene theory, in my opinion. It's inclusive fitness theory that really provides the odd fit in that case. That's how I would see it anyhow.
Yeah, I think it's what one should say, kind of organismic-centric inclusivism, because you can kind of take inclusivist models, right, and apply them to genes for cells. And then, like, that is the fitness maximizer. You can do these kind of really nice models in that way. So, like, the mathematical framework can be transposed. But I think, like, the tradition that's focused on organisms, while I kind of can very much sympathize with that tradition, I also think that it misses out on interesting things.
Yeah. Okay, well, now we get to the last 2. And this next one is super interesting. It's so interesting because in the development of the selfish gene concept, in some ways it emanates from Mendelian genetics. That's why you emphasize Ronald Fisher. But then it presents itself as an informational unit, that the concept of the gene is an informational concept, and therefore it does not really map onto any physical structure. Don't think of the selfish gene as a bead on a string. Okay, so you would think that when we make the jump from genes to memes, when we begin to think about cultural evolution, and we want to invent some gene-like concept for cultural evolution, let's call it memes, then because the concept of gene is an informational unit, then the transfer to cultural evolution would be straightforward, and that the meme concept would be proved to be a key concept in cultural evolution. And other than surviving as a meme, it proves that it turns out that no, actually, that hasn't proven itself very informative concept in the study of cultural evolution. The study of cultural evolution took a different path, represented by people such as Peter Richardson and Robert Boyd, Rick Michaud, who's right here, Joe Henrik, basically cultural group selection. So multi-level selection really comes into its own in the study of human cultural evolution. That's proven to be the productive paradigm. And the concept of memes, despite efforts, I mean, there were journals and books and so on, but it just didn't prove very useful to see cultural evolution in terms of little atomistic bits of culture. And so, Arvid, why don't we have your take on that? And then, but I think that's a very interesting point.
Yeah, I guess so. I guess I've thought much less about cultural evolution in general, but my impression is kind of what you described, that memetics was very influential in kind of like stimulating work on cultural evolution, but it's kind of like that fewer people these days are using that as a framework. I think there is kind of an interesting irony in that the gene side view emphasis on being very agnostic about the material basis of it, that the replicator was kind of an attempt to free the concept from restrictions of that genes are nucleic acids and so on. But it's exactly those kind of, there's certain kind of material properties that make it work rather well for organic as opposed to cultural evolution. That like problems with classical weaknesses of the mean concept, or kind of where one meme is meant to start and the other one end, and so on. What is kind of, what is even the notion of what's the difference between an allele and a gene, and when it comes to meme, I think these things come up already in the chapter on memes in the selfish gene. I think it's a fun thought experiment. I don't think it's one that really worked out, despite, as you say, efforts and some really enthusiastic converts to it. But I mean, yeah, it also highlights the gene side view has in some ways a very traditional notion of what a gene is. It's very similar to, or very much that of old school theoretical population genetics. This is something that is inherited intact. And then, you can read all these fun book reviews of the selfish gene from molecular biologists who are quite upset about the lack of respect paid to the hard-won insights about what a gene is, because the gene side view is quite happy to I mean, and I think it's ultimately it's a trade-off. You kind of choose to kind of focus on being quite agnostic about that, but you do that in order to kind of achieve other things. But I think it's an interesting kind of historical thing. I think that this field of cultural evolution today is dominated by other frameworks.
Well, to take a part of it, I mean, both for genetic evolution and for cultural evolution, there's a concept of evolution without replicators. It turns out that actually you can have an evolutionary process without anything that qualifies as a replicator. This is against the point that you made earlier, that only genes have longevity, because actually phenotypic distributions have longevity. And so the replicators, actually genes as replicators, probably that was not true in the origin of life, and it was something that happened somewhere along the way. And then when we get to cultural evolution, the concept of cultural evolution without replicators really actually is quite important. And when you look at why cultural evolution has any kind of high fidelity, it tends to be, for example, people invoke such things as cultural attractors and things like that. So basically, we have whole systems which are cohering as basins of attraction. And then we have multiple basins of attraction, and evolution takes the place of basically selection among attractors. There's no particles in there that you can point to. It's very systemic, top to bottom. And so I think that's one reason why the concept of some cultural equivalent to a replicator, it doesn't exist in many cases. The entire process is systemic, top to bottom. And of course, lots of people have made that comments about genes as well. I mean, the more holistic branch of systems biology has complained about the privileging the gene as opposed to the whole replicating unit for a long time. So these arguments do span both genetic evolution and cultural evolution.
Yeah, I think that's very true, and I think the kind of the central claim of the gene side view is that it is meaningful to divide up between replicators, the kind of entities who are passed on intact enough across generations to serve as the beneficiary of selection, and to contrast that with what has been called vehicles or interactors, the entities in which these replicators are bundled. And it's absolutely true that this is not as general of an account as one that kind of relies on this kind of minimalist criteria that was, Lewontin talked about, kind of you need heritable variation and fitness differentials, and then you're off you go. And kind of Petty Godfrey Smith has developed this into kind of Darwinian populations and so on. And I think it's absolutely true that those are more general accounts, that you don't need something to play the replicator for evolution by natural selection to work. That being said, given how life is organized on our planet, this kind of like replicator vehicle concept works really well I would say. So like, yes, I think you can, so even as a proponent of these view, I think you can see that there are more general accounts that could be developed, but I think then you could also push back to say, well, but given how life is organized on our planet and the kind of thing that we are trying to study, this works really well and turns out to be a really productive way to approach it.
Yeah. Okay, great. Well, so now last item, and I'll make it quick, so we could open it up for discussion, is the relevance of multi-level selection for public policy. And it really strikes me that the work I'm doing with the economist Dennis Snower on rethinking the theoretical foundation of economics, we call the new paradigm the multi-level paradigm. And there's a reason, I think, why multi-level selection really does become like the framework of choice for public policy. Why is that? It's because the original problem is all around us. If you look at any pathology that's happening today, what you find is the original problem. You find lower level units such as individuals or corporations or that are basically succeeding at the expense of more prosocial units. I sometimes say that multi-level selection is like a perverse alchemist that turns gold into lead. So you have individual self-preservation turns into self-dealing. We have helping family and friends turns into cronyism and nepotism. We have my nation's first overheating the earth. We have corporations maximizing their profits to their shareholders, resulting in a terrible economy. We're living the nightmare when it comes to lower level selection forces disrupting the higher level common good. And if we want whole systems to function well as systems, we must select at the system level. We must. And it goes way beyond anything genetic. My colleague Terry Deacon has a wonderful phrase. We are a symbolically eusocial species. The glue that holds our societies together is not our genetic relatedness. Of course, we still love our kin and so on and so forth. But the glue that holds our societies together is our symbolic meaning systems, how we envision ourselves in groups and so on, and so forth. And so if you really want to make something better, then what you're starting with are agents that are currently have evolved to operate at cross purposes with each other, and that's reducing suffering. And if you want to make it better, then you must turn these conflicting entities into cooperative entities by a process of deliberative, conscious, whole system evolution, of which there's many examples. And so multi-level selection is just becomes essential for the practical enterprise of making life better at all scales. And so I think Arvid, please respond to that, and then we can lead directly to a Q&A on that basis.
Yeah, and I guess that's one aspect of your work that I'm really curious about, and I'm kind of excited to be in this environment here, where I feel like people have thought about that. It all seems very sensible to me, but as it's kind of like I've thought much less about cultural evolution and kind of human society in general. But I'm very intrigued by the idea, and kind of particularly kind of in where that way of thinking leads to solutions or kind of policy proposals that wouldn't have emerged otherwise. Like what,
right.
what do we gain from taking this point of view that you wouldn't get from just
well, let's get
classical social democracy or similar, right?
Let's bring Rick into the conversation. You have to leave at the hour. Rick, that gives you 3 minutes, but you've been along this journey as long as I have and contributed very importantly to it. So, so if you wouldn't mind sharing your views.
Thanks, David. Thanks, Arvid. I did write something in the chat because I have to go at the hour, but so what I don't, the genes I view, what I don't get there, Arvid, is how it helps us understand evolutionary transitions in a kind of fundamental way. That is, I understand that, it creates our vehicles and so on, but the advantage of the multi-level selection view is that there's an imperative to being curious about how groups of individuals can evolve into a new kind of individual. That's the beauty of the multi-level selection framework. If you're interested in evolutionary transitions and where new kinds of units come from, it just invites you to be curious about that question. And I don't see that in the Gene's Eye View, but I haven't read your book. I want to apologize that I haven't read your book yet. So you probably have an answer for that.
So I do deal a little bit with it, and I'd be very keen to kind of continue that conversation at some point. I think like the Gene's Eye View very much highlights the importance of genetic relatedness in achieving the evolution of new levels, that you can only kind of do that by that level needs to be fixed in order to kind of move upwards. Because I think it's interesting, kind of, I think, contrasting your work on the one hand with like that of Andrew Bork in Principle of Social Evolution. It's also about major transition in a very gene-centric inclusive fitness kind of way, right? That like you can only achieve inclusive fitness maximization or like the emergence of new when kind of you have this unity of purpose. So I think the Gene's Eye View is good in that like it forces us to take that, it doesn't force us to think hard about how you achieve that.
But Arvid, you mentioned relatedness, but relatedness is really uninteresting in many of the major transitions. So if you look at hypercycles and the evolution of the genome, and if you look at the eukaryotic cell, I don't see the Gene's Eye View really giving us much insight there.
And so I guess so. I think for the eukaryotic cell is harder from the Gene's Eye View, and I think, but so, I mean, I think I agree. There is a good strong argument for taking multi-level selection point of view, and I think that's interesting in Maynard Smith's and Jatmari's original book, right? Maynard Smith was a strong proponent of the Gene's Eye View, but also that book clearly opens up our view to kind of thinking about levels of selection in a whole new way.
Yeah, I think that is a good example. So Maynard Smith, exactly as you said, yeah, in the case of major transitions, sure thing. And even if you want to use the language of selfish genes, I think you got to bring in vehicles, and I mean the convergence of language and so on, it becomes really isomorphic at that point. But to the degree that the major transition involves the conversion of a whole community into a superorganism, such as eukaryotic cells or of course microbiomes are super interesting in that line. So selection at the level of microbiomes. I think that let's bring. Don't want to privilege people asking questions, but Randy, I sure want you to talk, and then let's everybody line up by raising your virtual hands, please. And thank you, Rick, for coming. Everyone line up by raising your virtual hands, and don't feel like you're like not expert enough to ask questions, because that's just not the way we are. So but Randy, would you like to say anything?
Yeah, thanks, David. I have a question for Arvid, which I think bears on all of this. You were in Kevin Foster's lab at Oxford, I think, Arvid, and I've been very impressed by the study of bacteria as an optimal way of studying these kinds of cooperation. And I think the key concept, he doesn't put it this way, but I do, is costless enforcement. That is, individual agents do things that benefits their own genes, and that creates enforcement that creates higher level cooperation that does not need group selection for explanation. Could you comment on that?
Yeah, so I've collaborated with Kevin for many years, though I've never actually been physically in his group, but we continue to work on the kind of concept of enforcement. And so they're the idea that, so we have this one paper that from a couple of years ago now, simply called Enforcement is Central to Evolution of Cooperation, where we make the argument that if you take all kinds of cooperative systems, from molecular all the way up to interactions between species, and you line them up side by side, and you ask, what do they have in common? And then we say the thing that unites them all is that they have some sort of enforcement mechanisms that have evolved to suppress selfish behavior of other members of a group, and in so doing promotes cooperation. So this is a way of kind of unifying anything from like the suppression of cancer cells, silencing of selfish genetic elements, worker policing in new social insects, kind of sanctions in mutualisms. And there, kind of the cost of that, you can kind of, in all those situations, you can get the evolution of enforcement mechanisms from kind of strict individual level selection at all of those kind of levels up and down the hierarchy. You can do that, explain that, I think, from perfectly well, from kind of just thinking of each of those levels as being a group and explaining it from the member particles of those groups. Now, in those enforcement models, cost is a very big thing, and like kind of how costly it is to evolve enforcement or perform enforcement acts is kind of a crucial parameter. But I think it is a very kind of interesting lens, because it offers a way to think about the commonalities between different kinds of cooperative systems in a very powerful way that is kind of rooted in the observation that this is one thing that they all have in common. And we're currently still working with Kevin and Nick Davis, who's a mathematical biologist currently based in London, on kind of applying those to transposable element evolution, which is kind of self-generic element, but again, using similar kinds of thinking, that think of the genome as a group of genes and trying to explain it from the perspective of genes and their kind of social evolution. Yeah, so let me add to this. First of all, enforcement, absolutely critical. It's also critical to human evolution, basically, the fact that we're such a cooperative species. This is the work of Christopher Boehm and Richard Wrangham and Brian Hare. This concept of self-domestication comes into this, is that the reason we're so much more cooperative than chimpanzees is because we have bully control. Someone pushes their weight around within a group. Human groups typically have the collective wherewithal to oppose bullying and other forms of self-serving behavior. So social control is everything. It accounts for the compulsory nature of moral systems, the fact that moral systems aren't just about altruism, it's about norms that are enforced. And so social control is everything. It's important in every single group. The Ostrom design principles, if you know what they are all about enforcement. You can't just do what you want in a Ostromian group. But when we actually study this theoretically, and that then what we find is this. Also, the concept of fitness interdependence is part of this also. Basically, it's like we're all in the same boat. And I sometimes call this a no-cost public good. Let's say that we're a member of a group, and I'm the type of individual who can do something that benefits everyone at no cost to myself. And low-cost enforcement or no-cost enforcement, costless enforcement, is an example of a no-cost public good. By being a costless enforcer, I get rid of cheating, and everyone benefits in my group, including individuals that are not enforcers. So I ask you, where's the fitness difference in that scenario? Is there a fitness difference within groups in that scenario between the enforcer and the non-enforcer? No, it's neutral. In order to explain how that involves, that has to be the case that groups with costless enforcers do better than other groups. The model will tell you that. And so, yay for costless enforcement, but the idea that group selection doesn't need to be invoked, absolutely not. And any model will tell you that. So anyhow, I've had my little repost. Gary, Randy and I have been doing this for 40 years, friends. So don't think that that anything that's changed here. Randy, would you like to come back at that, and we could go on to other questions?
No, thanks. Go ahead and see what other people have.
Barbara.
So I'm curious, you talking about, bullying is not, it goes on, but because we have enforcement, so to speak, it's not acceptable. What do you say about the politicians? And I will mention Trump, who are getting away, and other politicians as well, that in certain sections of, I don't even know what to call it, the community, the human organism, there are certain people, Bolsonaro, Duterte, Orban in Hungary, these people get away. They don't seem to follow the rules, so to speak, and morality doesn't seem to apply to them the way it does to the other people within the group?
Yeah, well, let me give two answers to that and then turn it over to anyone who wants to comment on it. And the reason that there's two answers needed is that bully control is only sometimes successful. I think if you look at a moral system as like the immune system, always vigilant, often challenged, sometimes overcome. And so there's lots of forces of selfishness at work, especially the more subtle forms, which actually do manage to succeed within groups. And even when the group gets rid of bullying within its own ranks, then it can act like a bully against other groups. And here we get, our levels of selection. The group selection doesn't make the problem of bullying go away. It just creates group level bullies. And unless you do something about that, then of course you must do something about that. And so that's where we get our national bullies. So that's how I would. Arvid, do you want to say anything about that, or anybody else?
Yeah, I'd be keen to hear what people who have thought more about it have to say.
Yeah. Anyone else want to chime in on that?
I do.
Yes, Alonso?
Yeah. I think it relates back to the prisoner's dilemma. And the prisoner's dilemma shows the least fitness in the self-interested society and the greatest fitness in the cooperative society. And in a mixed society like ours, from what the lady said about Trump, it's the defectors, the self-interested, that gain predominance in a mixed society.
Yep, game theory has much to say about it in all its forms, and so absolutely right. And of course, we have social identities. If you regard yourself as not an American but as a Republican or a Trumpian or QAnon, then that's your us, and it goes on from there. Okay, what else would we like to talk about? Who else would like to add to this?
I have a question about adaptation in general.
Great.
Because genes aren't smart. They can't choose. And the concept of a selfish gene is only when it survives in one way or another. And I like Paul Ewald's dichotomy. He says there's two pathways for mutation to be successful, and that's adaptation. Is adaptation towards self-interest, toward more virulence, toward spreading to some other host, or it's adaptation toward commensalism, through living with the host and helping the host and finding a way to help it better. Does that fit?
Yeah, so the idea that genes have agency, Arvid, why don't you address that?
Yeah, so the way I think of it, I think thinking of genes as if having agency, I think is a tremendously powerful thinking tool. It's a really great heuristic. I think one can adopt like a gene's eye view perfectly well without talking about selfish genes in that kind of traditional Dawkinsian way. I think that was a very powerful way of introducing the idea. But the idea when kind of here then selfish is defined in a slightly unusual way, that like genes are here viewed as selfish as if because they're trying to be represented in the future generations, kind of making it to next generations. But then all genes are selfish in this way, right? And I think when something applies to everything, it becomes less helpful. And that partly explains the kind of vocabulary confusion that we had in what we now call selfish genetic elements, which are, here we use selfish in a narrower way, because selfish is defined in a way that it's kind of much more closely to how we normally use the word. It's something that's beneficial to that gene at the expense usually of other genes in the genome or even organismal fitness. And this kind of went through this kind of called ultra selfish genes or genomic outlaws or selfish DNA, genomic parasite, all these kind of things, I think very much inspired by the gene's eye view. But I think that kind of the selfishness in kind of when all genes are selfish, I'm less kind of less keen on, whereas I'm kind of perfectly happy to call kind of meiotic drivers, transposable elements, these kind of groups of genes that have the ability to promote their own transmission from parent to offspring, even at the expense of organismal fitness. So things like sperm killers that reduces the number of sperm produced, but these alleles are present in all the remaining ones. So even though the kind of fitness of the individual is reduced, that specific allele is overrepresented and can still spread in a population over evolutionary time, despite being harmful to the individual. So I'm perfectly happy calling that selfish. I'm generally quite fine with agential thinking, these kind of personifications. We have a paper that came out just the other day where we call for, try to argue for a case of license anthropomorphizing. And this is a term, license anthropomorphizing is a term coined originally by Alan Grafman, but we argue that anthropomorphizing can be a very helpful way to think about things, particularly genetic conflicts. But the license to be allowed to do so comes from formal modeling, so that you should then use this kind of personification, agential thinking, even anthropomorphizing. If I was a gene, what would I do in this situation? You can use that to generate ideas, and for that, I think it's extremely powerful. And for me personally, it's second to none in the kind of work that I do. But then you need to back it up with a model to show that the logic actually worked. And by kind of going through the work of building a population genetic model or a game theory model, or whatever kind of your weapon of choice is, it forces you then to kind of like become serious about things like the assumptions. And usually that you realize that you haven't thought of something, or that you've kind of just glossed over some sort of assumption. So in general, quite happy with calling personifying genes. But the kind of the general notion of that all genes are selfish, I think, is not necessary, although I think it was a very powerful way of introducing the original concept.
Hamza, you want to come back on that? I'll make a comment after you.
Yeah, I think that you're transferring meaning to the adaptation. I have a problem seeing genes as selfish, but when a gene mutates, or when mutation happens and it is successful in one of those pathways, then it's selfish. It wants to reproduce itself, and it can, and it does. But you're pro-social. I like your negative on memes not working, because pro-social is complex, like you point out. There are basins of interest, and there are many more elements than just one or two or even three in determining social acceptance and social survival. And so I have a problem. I can see the selfish gene expressed in both of those pathways. You know, why did endosymbiosis happen? Because it worked. And we have selfish trees and selfish animals because of endosymbiosis, because it worked. But I have a problem with the selfish gene.
Well, the concept of licensed anthropomorphism, I think, is interesting. I wouldn't call it anthropomorphism. What would I call it? Licensed intentionality, or something like that. Basically, you're assuming that this thing is an intentional agent, and then you have some license to do it. And obviously, there's some sense in which you have to. I mean, it's helpful in terms of making predictions. And you said, Arvid, that you have to, I mean, the license comes with carefully modeling it. But I would also argue that if we take Tinbergen's 4 questions seriously, function, history, mechanism, and development, that when we get to the mechanism question and the development question, the more proximate causation questions, then that's where we really have to depart from the licensed intentionality. And so, for example, with the study of social insects, you can say, yeah, the colony is highly related, and so therefore workers should work for the benefit of the sisters and here and out there, so on. And you think of the individual worker as an intentional agent, basically following Hamilton's rule, come to study actually individual social insects, they don't think that way at all, not even close. And they're much more a part of a group level organism, acting more like a neuron than like a decision-making unit at all. The decision-making in a social insect, actually, there is many decisions that are made by individuals, but many other decisions are so distributed that the only way to understand the role of the individual is as part of this, as like the way you would study a single neuron. And so I think that when it becomes mechanistic, then I think the fiction that this agent is a intentional agent it's a fiction and it has to be abandoned as such. How would you respond to that?
Yeah, I guess there are two things. I mean, I think like depending on how you view the world, different things stand out. Different questions demand different kinds of tools, different kinds of answers. So like for certain ones, the more kind of proximate questions, I think they want the kind of tools that are so helpful and productive for evolutionary ultimate questions may not be as potent there. I think that's perfectly fine. The way that this kind of paper came about, this licensed anthropomorphized methods, this paper with Manners pattern, partly it stemmed from that we are both interested in genetic conflict. And genetic conflict as a kind of research area is fun for many reasons, both partly the weird and wonderful biology that it deals with, but also because it's kind of like it's an area where two kind of broad traditions come into contact and sometimes clash. So kind of people who studied genetic conflicts have generally come from two main areas. So one is kind of what you can describe as kind of like a social evolution, behavioral ecology tradition, people interested in conflict and cooperation in general. So like they've studied in animals, and then they kind of turn their gaze to genes, and then often they kind of bring with them a comfort with agential, intentional thinking, talking in terms of intentions, strategies, purposes, and so on. It's kind of a language that's much more common in that tradition. There, however, you kind of come into contact and clash with kind of a population genetic tradition, which is much more quite unhappy with that. They have rejected maximization approaches for a long time ago. Just want to kind of like describe the phenomena in terms of mutation rates, effective population sizes, selection coefficient, P's and Q's, and so on. And we thought it was fun when you read the reviews of Genes in Conflict, this majestic book that Austin Burt and Robert Trivers wrote about the biology of self-genetic elements, came out some 15 years ago now. It was reviewed by Brian Charlesworth, kind of the grand old man of British population genetics. And he very much like lauds the book, saying that this is it's an incredible book. But then he kind of ends with like, my one criticism is that the language is often surprisingly anthropomorphic. And then he goes on, evolution is a mechanistic process. There's no one wants anything, and so on. And I think that in some ways that kind of encapsulates that tension that does exist in it. And as a part of this paper, we also trove through the old literature about all this kind of fun insults people have thrown at each other in this kind of clash. Because I think it's an interesting window into two different traditions in evolutionary biology.
That even exists. That even exists just for straight up evolutionary biology between population geneticists and behavioral ecologists. Totally,
it's just it plays out nicely here, and it's an area that we know well. And I think we also made a case that like for certain kinds of problems, kind of a straightforward being kind of putting your PopGen hat on is very helpful. For some other problem, like the kind of intentionality is really good at identifying the kind of where the evolutionary action is in a way that the mechanistic PopGen models struggled to do.
Yeah, well, we're coming to a close here, and what I would love to have is some basically, if I could be bold enough and you could be brave enough to just to reflect a little bit on what you've been hearing. Let me start with Kurt, and just call upon some people. And if you want to preempt me, then you can put your hand up just for some thoughts as to what this means or how this landed with you or anything, because your thoughts are very useful wherever you're coming from. I think that I really want to know where the connection is. So Kurt, would you mind speaking?
Yeah, well, it's always interesting for me, you know, because my PhD's in evolution, though it's macroevolution instead of genetics up, and then all my work in comparative religion. But this has been really useful to me because I'm actually editing a book now for Ervin Laszlo, who's 90 years old. So many of his perceptions run exactly in these directions. It's quite amazing, but he's not caught up on the literature that actually supports those views. And that's kind of my job in working with him, is to catch him up. So long story short, so many of the things here, and of course, copying out the chat, which I'll do, extremely useful to that little task that's ahead of me. So I want to thank everybody.
Okay, great. Thanks. Well, now I'm going to pick on Joe Alcock here. Are you there, if you don't mind?
Yeah, you bet.
Let's see. There you are.
I missed the beginning part of the conversation, and I would say, Arvid, that I very much enjoyed your book. I think it's a great update and a synthesis of thinking about the applicability of selfish genes. I guess I'm interested in how we think about this scheme in terms of the microbiome. And it seems like most of the commentary among microbiome scientists emphasizes its cooperative interactions with its host and tends to downplay conflict. I think that they're both important. And I like your point that enforcement is maybe you, David, you made this point that enforcement is important in making cooperation happen. And clearly we can have cooperative interactions with our microbiomes. And yet we should expect that cooperation should be fragile. So I would like to hear either one of you guys respond to that.
Yeah, thanks. Joe, I have to ask, who's your father?
My dad's John Alcock.
Okay, I thought so. A very, very famous person in this field.
Yes, I definitely grew up with this it was in the ether as I was growing up. And so
absolutely, I can well imagine. He was one of the great fathers of sociobiology. So,
right.
So you have a very distinguished dad. Arvid, first you, and then I'll.
Yeah, well, first of all, thank you. That's very kind of you to say. And I think holobionts is interesting, right? Because like mutualisms, it doesn't work with straightforward kind of genetic relatedness and the kind of genes, fitness, interests aligning. I think my impression of the holobiont field is that it, at least for a while, was very like focused on the microbiome as this one entity that's very cooperative, both within it and also with the host. I think like a gene's view is perhaps can fall too much on the other side. It's very often very good at pointing out that not all entities of a group will be cooperative. It's quite conflict-centric. So I think that it kind of like highlights that there are many reasons to expect that both individual bacterial strains will come into conflict with the host organism, but also with each other. That like that ecosystem probably is, as like any ecosystem, a mixture of mutualistic, commensalistic, parasitic, competitive interactions. And I think that the focus ought to be on characterizing that. And I think kind of like to if you want to take advantage of the whole biome system, you need to understand that. It's partly like I've become more interested since I've recently moved to Cleveland, Ohio. I'm spending a lot of time at the Cleveland Clinic, working in kind of affiliated with a research group that work a lot on cancer evolution and kind of trying to understand. And their idea is that if you can kind of understand the interaction between different strains in heterogeneous tumors and kind of affect their ecological interactions, if you will, that gives you a better starting point to the way you should treat it. That they kind of depending on those ecological interactions, treatments should vary with that. And if you can kind of push this ecosystem, if you will, in one direction or another, that will have benefits. And I think kind of the holobiont has very much kind of similar kinds of properties.
Yeah, so the way I'll add to that is, in the first place, it's an empirical question as to whether our microbial communities are good or bad for us. And my understanding of the literature, I'm not an expert, but my understanding of the literature is, yeah, actually, yes. And so much so that now obviously we get diseases. and also the degree of interaction between our genotypes and our microbiomes is, amazing, to the degree that our genotypes are actually, if you could remove our microbiomes, it would be terrible for us. But theoretically, here's something that's really interesting, which is that variation is scale independent. You can imagine an ecosystem with, many thousands of species and many trillions of individuals. Just by the laws of sampling error, there'd be almost no variation among individuals, especially if there's a lot of horizontal transfer and stuff like that. But au contraire, if you actually do experiments, as we did, on creating microbial ecosystems in the laboratory and selecting them, what you find is, dang, if they don't vary, and the reason is that even though if they start out almost identical, then because they're complex systems, sensitive dependence takes over, and they become different from each other. And so this is, I'm not being very clear about this, but when we're dealing with the evolution of complex systems, then most of what we think about variation and selection and heritability, we have to rethink, because our intuition is based on additive models. And those additive models tell us, for example, if you initiate groups, the more individuals you initiate the group, the less variation there is within groups, and all of that, the importance of genetic relatedness, all hinge on actually very simple additive models. And so again, I feel like I'm not conveying this point very well, but if you go to cultural evolution, it doesn't matter how big the unit. Nations are huge, millions and millions of individuals. Businesses are they all vary because they're path dependent. They're highly path dependent, and so variation, you always have variation. And then there's the question of, do you have heritability if you select upon that variation? So it's in that sense that I think that that should inform the study of microbiomes. I don't know if any of that landed, but in any case, oh, it's 7:30. We'll hear from one more person. Dinah, can you say something as the last person? Can I pick on you?
Yeah, absolutely. So I am Rick Michaud's former student. I work on the evolution of multicellularity. And I think one of the things that most resonated with me was actually what you were just discussing a moment ago about the importance of path dependence and the sensitivity to initial conditions. So when I do experimental evolution on the evolution of multicellularity, I see that I have a number of replicates set up, and I saw a number of different outcomes, even starting from those exact same genotypes. So that really resonated with me. The other thing that I'm really taking away from this discussion is the societal importance of considering these prosocial interactions. Rick's group, including myself, has been working on an education on bringing multi-level selection into education. So teaching middle school students about cooperation and conflict. And we've been doing that at the university level as well. And this has just given me a lot to think about in terms of the greater benefits of this approach.
That's great, Dinah, and we'll be in touch because the Prosocial World, the nonprofit organization that sponsors this, is well funded and prepared to actually study this in the real world context, and that involves everything from just basically continuing the theoretical conversation, catalyzing that, I think, continuing to what I see as a resolution of decades of controversy, and then applying it to real world situations. And so, yeah, I'm lovely to know that you're already doing this in an educational context. And so please, everyone, keep that in mind. And that's one of the reasons why I was so happy to have a conversation with Arvid, and I think that I would certainly want to include everyone involved in this. Now that we're really becoming literate, becoming multilingual, as I like to put it, we can get on with it, and actually with the business of expanding prosociality in the real world. The world needs these ideas, friends. It really does. Anyhow, so thank you, everyone. And we have you as a registration list. And as we continue to move forward, then we do have a way to reach out to you. And please reach out to us also. You could type hello at Prosocial World right there. And then we could initiate a conversation, and happy to have you be the ones who make the next move. Thanks, everyone.